So make sure you take this warm-up seriously so that you can be ready for one of the questions on your assessment. First, you need to fill out the similarity statement, and then you need to solve for x. We want it to be exact, so that means no decimal answers, please. You can't turn a square root into a fraction. You can't like do math enter, because when we get the answer to a square root, it's an irrational number. You cannot represent irrational numbers with fractions. So you need to factor tree it. You need to simplify the radical. You need to pull out the perfect squares, okay? So just a hint, you are going to use geometric mean. And yes, you need to re-memorize these proportions for your assessment. Yes, you need to re-memorize these proportions for your assessment. All right, now when we are writing a similarity statement and you don't know what order to write the letters in, sometimes it helps to make up angles. So I recommend on the assessment, if you get stuck and you're not sure which sides go with which sides, that you can make up angle measures. So I'm going to make up an angle measure. I'm going to call this angle 20 degrees. Well, if that angle is 20, and we already know this angle is 90, then 90 minus 20, the complement of 20, will give us our other angle. So this angle is 70. Well, if that angle is 70 and angle M is 90 degrees, then this angle is 20, and if that one's 20, then this makes that one 70 right there. Okay? So now I have all my angles labeled. Now I can write my similarity statement. Triangle MNO. So when I name that, I think I meant to name the big triangle first, but it's not a big deal. MNO is 20, 90, 70. 20, 90, 70. So now I need to name all my other ones with 20, 90, 70. Let's do the medium one next. We're going to go small, medium, large. Okay, 20, 90, 70. P, N, M. Are we okay with that? 20, 90, 70. Now we're going to name the large one. We're going to go 20, 90, 70. P, M, O. And I know that sounds silly, but it is important to name them in the right order so that you are matching up your corresponding parts of your similar triangles. The order matters. All right, now let's solve for x. X is a leg or an altitude of the big triangle. A leg or an altitude. It's an altitude, so this is the chosen formula. Hint, hint, maybe you only need to memorize that one. Hint, hint, wink, wink. Okay, so segment 1, so a segment of the hypotenuse over the altitude equals the altitude over the other segment of the hypotenuse. Cross multiply. X squared equals 4 times 8. X squared equals 32. And here's where it changed from last unit. Last unit, you would have just done square root of 32 in your calculator and you would have put a decimal. But now we know how to simplify this. I'm just going to stop there because I found a pair. 4 root 2. Root 2. Answers to your homework. It was short and sweet. 12 problems. Let me know if you would like me to work some. Test, root test. Oh my gosh. Okay, I'm starting with number 6. Let's go in order. 6, 3, 7. So number 3 first. So we're going to factor tree the 63. What'd you use? Maybe 7 and 9 prime, 3 and 3. Okay, so this is equal to 1/3 3 root 7. The 3 escapes and the 7 is stuck. What's 1/3 times 3? They cancel. It's just 1. 3 times a third is just 1. So the answer to number 3, this is number 3, is square root 7. The 1/3 and the 3 cancel. 1/3 times 3 is 1. Okay, number 6. Number 6 is I'm pretty sure number 6 is literally the only one from your whole homework where you had to rationalize the denominator. You didn't have to do it on any other problem of your whole homework. Crazy. All right, we need to rationalize the denominator. The way that we rationalize the denominator is we multiply the numerator and the denominator by the radical in the denominator. We're going to multiply across. 3 times root 7 is 3 root 7. Square root 7 times square root 7 is plain old 7. So that's how you do number 6. Number 7 from the homework. When you have 2 radicands that are divisible, when 6 is divisible by 2, you're allowed to divide those because they're both radicands, they're both under the radical. So you're more than allowed to write this as square root of 6 over 2. That's the square root of 3, and you're done with that problem. No need to rationalize the denominator because 6 was divisible by 2, and you're allowed to combine them because they are both radicands. Okay, number 4 from the homework. Square root 18 times square root 6. So we learned that when we multiply radicals, we multiply the numbers on the outside separate from the numbers on the inside. Well, on the outside, we just have 1 times 1, so we don't need to worry about that. On the inside, we have 18 times 6, so we are really simplifying the square root of 108, 18 times 6. Now, you could just use those as your factors if you want, since we already know that those two things multiply to get 108. And we have a 3 that escapes. We have a 2 that escapes. Cross them out as you go. And then we have a 3 left over. So we have 6 square root 3. Last one, number 9. I talked about yesterday how you need to be on the lookout for perfect squares. You need to be on the lookout for perfect squares. 8 over 25, that is not reducible. You cannot simplify that. So my first step would be to write that separately. And then you should recognize that, oh, ooh la la, 25 is a perfect square. So I can just write the denominator, it's just 5. The square root of 25 it's equal to 5. And now all I have to do is factor tree the top one. Square root of 8 is 2 root 2. And so the final answer is 2 root 2 over 5. And you're probably thinking, Miss Stanton, we've already learned Pythagorean Theorem. In fact, we learned it before we got to your class, and then we learned it in your class. Why are we talking about Pythagorean Theorem again? The difference is this time is that we know how to get our answers exact this time instead of approximate. Before, we would just take the square root of 58, and we would just get a decimal, and we would write it down. We're not doing that anymore. From now on, our answers can be exact. We're going to factor tree square root of 58, and we'll know the exact length of the missing side instead of a decimal approximation. Okay? So that's what we're doing today with Pythagorean Theorem. Pythagorean triples. I don't know if I talked about this the first time I introduced Pythagorean Theorem, but Pythagorean triples are way more useful than you think. Pythagorean triples are sets of whole numbers that satisfy the Pythagorean Theorem. I am just showing you 4 examples. Later, go Google Pythagorean triples and look at all the multitude of triples that are out there. Now, you can take any of these triples and you can multiply them by an integer and come up with another triple. So like 3, 4, 5, that forms a right triangle. 3 squared plus 4 squared is 5 squared. But I could double all of them. So another triple is 6, 8, 10. Those numbers satisfy Pythagorean Theorem. 6 squared plus 8 squared is 10 squared. I could triple it. 9, 12, 15. That is a Pythagorean triple. So, like I said, Pythagorean triples are numbers that satisfy the Pythagorean Theorem. If you memorize them, they'll make some of your problem solving a snap. They'll make it so quick. 5, 12, 13, that's one of them. Yes, there's millions. Okay. Because you can just keep multiplying them by a higher number and a higher number. Okay. Anyways, we'll get to Pythagorean triples later. I'll let you know when one of them shows up, okay? Find the value of x and leave it in simplified radical form. So see how we're taking Pythagorean Theorem and we're like stepping it up a notch. So we're going to do what we're used to doing. A squared plus b squared equals c squared, but now we know how to work with radicals. 25 plus, what's the square root of 3 squared? 3. Alrighty? So now we need to reduce the square root of 28. Very good, 2 root 7. So the final answer is x equals 2 root 7. That's what it means when it says to give me an exact answer or to leave in simplified radical form. Very good. Next one. We know we're looking for a leg. We're not looking for the hypotenuse. So we need our number to be smaller than the hypotenuse. So we're going to subtract 25 squared minus 12 squared. .481 equals x squared. Does 481 have any factors? It actually does, yeah. .13 times 37. The problem is, though, that 13 is prime and 37 is prime. And so we have no pairs at all. And so actually, that is our final answer. X is the square root of 481. That is the simplified radical. I know that's weird, and I know you really just want to put what it is as a decimal, but that is the exact answer. Yeah, it's just beautiful. Okay. Next one. This is a Pythagorean triple. So if you've memorized your triples, you don't even have to do Pythagorean theorem. You're like, oh, that's a 6, 8, 10 triangle. Remember, 3, 4, 5, 6, 8, 10? If you just memorize them, then by golly, you're going to be done with this problem very quickly. Look how fast I solved that. I hardly did any work. It's a 6, 8, 10 triangle. If you don't memorize your triples, that's okay. You go off to the side and you do 10 squared minus 8 squared. And you will get 36 equals x squared. And then you will take the square root, and the square root of 36 is 6. If this is 6, and this is isosceles, then that has to be 6 as well, because that segment is a median. And so x would be 12. No work for once. Look at that one. Is that a Pythagorean triple? Let's see. 3, 4, 5. But if I triple it, it's 9, 12, 15. Is everyone seeing that? If I triple each of those, triple it, triple it, triple it, that's a Pythagorean triple, 9, 12, 15. You don't have to use Pythagorean triples if you don't want to, okay? You could always do 15 squared minus 9 squared to get this value right here. I'll call it y because I don't want to call it x. We already have an x in our picture. So y is 12 when you do Pythagorean theorem. Y is 12. Now, if this trapezoid is isosceles, like it is, then we know that that little wing on that side is going to be 12 as well. And we know if this is 10, then this segment is going to be 10 as well. So everyone's saying 34 is totally correct. X is 34. Very good. We okay with that? So we're using Pythagorean theorem, but we throw in a few steps afterward. It's not just plain old triangles. Try that one. I love it. It's so fun. There is going to be a quiz in the future where it's going to be this picture, but there's going to be like 6 triangles instead of just 2. It's going to be like this triangle helps you find this triangle, helps you find this one, and it goes in like a spiral, like a little shell. It's so cool. Yeah, it is easier than you thought. Hexagon? No. Okay, anyways, we're going to start by doing a squared plus b squared equals c squared. Square root of 2 squared is 2. The square root of 3 squared is 3. So 2 plus 3 equals c squared. 5 equals c squared. So what's the length of his hypotenuse? Square root 5. Very good. So this value right here is square root 5. Now we have to do Pythagorean Theorem again with a and b. A squared plus b squared equals c squared. 4 plus 5 equals c squared. Oh, doesn't that work out nicely? 9 equals c squared, or x squared rather. And so x is the square root of 9. X is 3. That wasn't so bad after all. Isn't it nice when you get an answer that's an integer? I actually think I understand. Oh, good. All right, draw yourself a picture. The diagonal of a square is 13 centimeters. Find the length of the sides of the square. So hopefully you're beginning this problem with a picture. Draw yourself a square with a diagonal. We know squares have 4 right angles. The diagonal of a square is 13 centimeters. Find the lengths of the sides of the square. What do you want to do? What can we do here? Triple? No, this one's not a Pythagorean triple, because that would make it a rectangle. If it was 5, 12, 13, that would be a rectangle and not a square. X squared. Almost. If this is really a square, guys, then all of the sides are x, because in a square, all of the sides are congruent. Yes, Quan? See that? So now I can do Pythagorean Theorem. A squared plus b squared equals c squared. Do you see what's going on here? Yep. 2x squared equals 169. What do we do next? Divide by 2? Oh no. X squared equals now what? Not x squared. I'm already square rooting it. So x equals. So now I would do what we were practicing in class yesterday. I would separate this. Oh my goodness, I can't write. Okay, I would separate it. Square root of 169 over the square root of 2. The square root of 169 is back to where we started, 13. And then we have to rationalize our denominator. Square root 2 times square root 2 is 2. 13 times square root 2 is 13 root 2. And we just went from a pretty answer to an ugly answer. The answer is 13 root 2 over 2. I know. I'm sorry. This is what makes it K level. This is what makes it high school level. Because you've already seen Pythagorean Theorem before. We have to step it up. Wait, why 2x squared? Because x squared plus x squared is 2x squared. And that 2 caused us a lot of trouble, didn't it? Sure did. Karthik, so we have a right triangle. And this is a squared plus b squared equals c squared. I was using Pythagorean Theorem. I did just say the answer. You're right. This one is a very basic one. I want to try to get to the ones that are not as basic. You can do this one the perfect square way, because I know some of you like that because it's not as tiring as the factor tree way. So if you split that up into a perfect square times a prime number, Then the square root of 36 is just 6, and then we have our root 2. So remember, you don't have to factor tree it. If you know a perfect square that divides into your radicand, you can go with it that way, okay? Next one, try this one. I'm seeing lots of good answers. We can treat this one with a perfect square way as well. It's 7 times. I know that 50 is 25 times 2. And I know that the square root of 25 is 5. And so we get 35 root 2. Remember that you can always check it in your calculator by plugging in the question and then plugging in what you got and making sure you get the same answer both times. Let's try some multiplication ones. There are multiple ways you can solve this problem. I'm just going to do it the most direct way. Not the most direct, but the one that might come to you first. We learned that you multiply the numbers on the outside separate from the numbers on the inside. So you do 6 times 2, which is 12, and then you do 3 times 12, which is 36. Guys, 36 is a perfect square. There's no excuse from now on. You need to know your perfect squares because they show up a lot. So this is literally 12 times 6, because the square root of 36 is 6. It equals 6. No need to factor tree perfect squares. Don't ever factor tree a perfect square. And so you come up with 72 as your final answer. No radicals in your answer. 72 is the answer. Remember that for an answer to be simplified, you are not allowed to have radicals in the denominator. So on this one, we're going to do what's called rationalizing the denominator. 3 times square root 2 is 3 root 2. Square root 2 times square root 2 is plain old 2. Just like that. 3 root 2 over 2. Last one for today. So make sure you're looking to see if the radicands are divisible. Is 27 divisible by 3? We had one like this on our homework, I think. 27 is totally divisible by 3. You're allowed to combine those. You're allowed to divide these. 27 divided by 3 is 9. 9 is a perfect square. So our final answer would be 1/2. Very good. Final answer, 1/2.